Hello and good afternoon, everybody. This is Scott Cione in for MFA Media Group. Ladies and gentlemen, we've had a magnitude 8.1 earthquake that has hit 115 kilometers east-southeast of the Fiji Islands. And ladies and gentlemen, if you remember our live stream last night, whenever we were talking about the earthquake in Japan, I was mentioning that there was a very, very high possibility that more larger earthquakes would occur. Now, I didn't think these earthquakes were going to occur this fast. And after reviewing some information on the Solar Dynamics Observatory, dealing with the coronal hole that we were discussing last night during our live stream pertaining to Japan, the coronal hole and the solar wind has actually picked up. And I'm going to go over some of this information with you, and I'll go pretty slow for all of the newcomers that don't really know what I'm talking about. I'm going to try to explain everything to all of you in layman's terms. But ladies and gentlemen, this was a devastating earthquake. Now, when I mean devastating, this time I don't mean as far as destruction on land. This earthquake occurred out in the ocean. Now, right off the bat, there were no warnings of tsunamis. And one of the main reasons why there would not be any warnings of tsunamis is this earthquake was 669 kilometers deep. That is equivalent to approximately 415 miles deep. And normally, ladies and gentlemen, whenever you have shallow earthquakes that are near the surface, those usually tend to produce tsunamis. So, we're going to go ahead and get into some of this information that I have for all of you. And I'm going to jump right over here. We're going to take a look at the tsunami warnings. And there's no warnings, which is pretty good, because if this was a shallow quake at a magnitude 8.1, I would not want to be anywhere in the Fiji Islands. I wouldn't want to be anywhere in the northern islands of New Zealand, and not even on the eastern coast of Australia. Fortunately for all of these folks that live in these areas, this was a very, very deep earthquake. Now, yesterday, I really didn't get a chance to talk about the massive magma plume that is underneath the Pacific Ocean. Basically, the central and south part of this massive body of water. I have a cross section of this magma plume, and I'm going to go ahead and bring it up for all you guys so you can see this. And this is what I'm referring to. Now, this is on a much, much smaller scale, and it may be hard to grasp the magnitude and the size of this magma plume. And this magma plume, the bottom levels of it, way down here at the bottom, as you can see, I mean, these go very, very, very far deep into the mantle of our planet. And then here you have this other lava pool, and this is basically the liquid lava. You can see the Marquesas and Tahiti and Samoa and Pitcairn volcanoes and islands. Here is Hawaii right up here. And usually when these volcanoes are erupting, this magma is coming from this section here. Now, normally, whenever we see these much, much larger, I'm going to go get another cross section here. Whenever we see these very, very deep earthquakes, this is coming very, very deep at the bottom of this magma plume. Okay, and this is a kind of a 3D cross section. And again, if you haven't studied this for a long period of time, this graph actually means nothing to you. So we're going to go ahead and start looking at some other information. Excuse me. We're going to go ahead and pull up the earthquake map. And this area is still rocking and rolling with the earthquakes. 50 minutes ago, magnitude 5.5. And as you can see, the depth, 643 kilometers deep. That is just about 400 miles deep. And there have been some smaller earthquakes. Now, this one, a magnitude 4.9, was only 10 kilometers deep. There's another one snuck underneath here. Let me go ahead and get to it. Now, this one was pretty deep, 541 kilometers deep, magnitude 4.7. Really not much to write home about as far as these smaller earthquakes go. They get this type of activity here all the time. But what the issue now is, folks, when we have these very deep earthquakes in this region, and the majority of the time they are very deep earthquakes down here, that pressure, that energy, it tends to move in this direction. Just follow my cursor. It tends to move in this direction. Okay, we have an update that just populated. But when we have these earthquakes down here, they'll tend to push towards Mexico, Central America, the northern part of South America, and about right here in the central part of the western side of South America, specifically Chile. So we're going to be watching this area very, very closely from Southern California all the way down the coastline of western South America. So I'm going to go ahead, just give me 1 second. I'm going to go ahead and turn the chat on in case any of you guys have questions. Just give me 1 second. This was a very, very strong earthquake. Boy, I was very, very surprised to see this earthquake occur today. Actually, I was kind of thinking that it would be maybe 2, 3, maybe 4 days from now, or actually from yesterday, that this earthquake would have occurred. But we're going to go ahead and move over to the USGS. Now, they have already downgraded this earthquake from an 8.1 to a 7.8. Now, folks, I'm going to be very realistic with you. The USGS, they're known for this, okay? Now the European Seismic Agency, over the course of the last couple of years, they've been doing the same thing. They don't want these earthquakes reaching over this magnitude 8. That seems to be their trigger number. But a magnitude 7.9, 7.8, 7.5, folks, these are very, very, very strong earthquakes. So let me just clue you in. If this earthquake, even though it's been downgraded, was to happen in, say, Southern California, well, we would be in a state of emergency. This would have toppled buildings. I mean, this would have been total devastation if this occurred on land and it wasn't as deep as it was. So, 669 kilometers is 415 miles deep. Okay, that is very, very, very far. That is the reason why we did not have any tsunami. Now, there could have been a displacement of this magma in this massive magma plume that is under this region. As I stated yesterday, and I'm going to go ahead and pull up the information here real quick on the SDO. Now, you're looking at the sun, and you're looking at this black hole, this region right here that just passed us by. Now, the Earth is located about right where my cursor is, about right here. So that means that we were directly in line with all of that solar energy streaming directly out of that hole, coming directly towards Earth. Now, as I explained in my live stream last night pertaining to Japan, when those heavily charged particles impact Earth, they will make their way all the way down to the core of this planet. They will heat the core up even more. So basically what you have is an expansion. When you have these expansions, you are going to have an increase in seismic activity, depending on how much of this stream was impacting Earth. Now, I've been looking at some of the information pertaining to our magnetopause, our magnetosphere, and a solar wind model. And I'm going to show that to you. However, we are not by any way, shape, or means out of the woods yet. Because as I stated in the live stream last night, we now have a much larger coronal hole that is forming to the left side of the sun, and it's forming right in front of your eyes as we speak. Now, what you're looking at right now is the Solar Dynamics Observatory. That is our sun. Now, this is in 211 angstroms. That's why it's in the color purple. It allows us to see the surface or the atmosphere of the sun. And when you look at the black region down here, and as you can see, this coronal hole is opening up, and it's opening up very, very fast. That will be Earth facing within the next 8 hours. The solar wind that will come from that massive opening will start to impact Earth very soon, within the next 8 hours. There's a very high possibility, ladies and gentlemen, that we may have another very, very large earthquake. But I don't think it's going to be anywhere in the South Pacific region. Usually, these deep earthquakes travel directly eastward across the Pacific Ocean. We may see a massive earthquake somewhere along the shoreline or just inland in Mexico. We saw that last year right near Mexico City. Hundreds of people killed, a lot of children. We may see a massive earthquake in Central America, or possibly the west coast of South America. I mean, your guess at this time is as good as mine. Excuse me. So this is what we're dealing with right now. And that is what we were dealing with a few days ago. But this energy is still making its way towards Earth. We'll have a small lull period right here in the middle, and that's a lot of activity also. We could have a solar flare or a coronal mass ejection from this area at any second. Hopefully that doesn't occur. And again, remember, right where the tip of my cursor is, that's right where the Earth is. So we are just slightly below the middle point of the sun, or as we refer to it, the equatorial region. So we are just below that line. If you just draw an imaginary line straight across the sun, we are just below that. And as you can see, as this next coronal hole moves in within the next 8 hours, that stream of those heavily charged particles is going to continue to bash the Earth. And that will probably continue for, well, anywhere from 12 to 24 hours. So we're definitely going to have to be on guard when it comes to these earthquakes. I would not want to be living on the west coast of California right now, Mexico, Central America, or the west coast of South America. That much is for sure. So this is the region. I'm going to go ahead and pan out here a little bit so you can actually see where it was. And, this is a very, very strange area down here. And you can see at one point, you could see the lay of the land. You can see these red lines are actual fault lines. And you can see this actually occurred between two fault lines. One here, stretching right through Vanuatu, and the other fault line right between Samoa, Tonga, and Fiji. Now, I'll tell you this much. The folks down here in New Zealand, even though they have their daily earthquakes, magnitude 3s and 4s, and it kind of shakes the island, they're pretty used to it. But remember, folks, 2 years ago when they had that devastating earthquake in the high 7s, they are still repairing damage from that time. If a shallower earthquake would have hit even this far up near Fiji, and that would have been a shallow quake, that would have sent a tsunami wall of water straight towards the northern island of New Zealand. How big it would have been, your guess is as good as mine. But this energy is going to push this way, straight across the ocean. And folks, that's just the way that it happens. After years and years and years of following earthquakes and learning some of the science behind it and learning what is underneath the Pacific Ocean. It's amazing. So I'm going to go ahead and take a look at some of the heliplots. And this earthquake, again, it was felt straight through the earth. And when I mean straight through the earth, I mean straight through the earth. Now, I'm not saying that people on the other side of the earth felt it, but the seismic devices that are all over our planet recorded this event. So you're taking a look at Barbados here. You can see listen, that is one hell of a burst right there. I mean, that is absolutely strong. Very, very strong. We're looking at Panama. Panama picked it up. Grenada. The Turks and Caicos Islands. Cuba. That was felt very strongly by the seismic devices there. More of Central America and the Caribbean, the Dominican Republic, Jamaica. This is the West Indies. Honduras. Look at that. Felt all the way through into China. Here's more from China. More from China. And here's some activity in the Aleutian Islands off of the coast of Alaska. New Mexico. I don't know why New Mexico is in here. This is actually supposed to be the international. This is Turkey, the country of Turkey. Seismic devices were picking this massive earthquake up. Now, it was felt all the way up in Russia. I don't know exactly where this seismic device is here in Russia. It must be a little further away. All the way down in the Antarctic at Casey Station. And again, they have Missouri in here, all the way up in Thailand, Oregon, Alaska. And we're going to go ahead and jump out of here, and we're going to look at some of the United States. New Mexico, Alaska, Missouri, Oregon, even all the way over in Florida, seismic devices pick this up. The state of Texas, Massachusetts, and naturally, seismic devices in Hawaii would have definitely picked that up. Standing Stone, Pennsylvania, South Dakota. So, ladies and gentlemen, you can see the magnitude, the amount of energy that just flowed straight through the earth. And again, I do believe that we are going to see probably another larger scale earthquake. I hope my predictions are completely wrong. But ladies and gentlemen, I've been studying these earthquakes and volcanoes, and I've been studying the sun for more than 20 years. And as we're looking at this data all combined together, this is the perfect induction for large-scale earthquakes. Usually, you have to have a couple of these factors come into play. Now, normally, you can have some of those uplift earthquakes and the sliding earthquakes where you have two plates sliding together, similar to the San Andreas Fault. And that's always constant movement, and you're always going to have the constant little earthquakes. But ladies and gentlemen, what's happening now is something totally different. You're talking about massive amounts of pressure that is building within our Earth. If any of you have ever placed an uncooked egg, in the microwave, and you turn that microwave on, what normally happens to that little egg? Once that internal pressure starts to increase, because a microwave cooks food from the inside out. So basically that's what's happening to the Earth when we are under the influence of these coronal holes, these heavily charged particles coming from the sun. As I've mentioned earlier in other broadcasts, our magnetosphere that protects this planet is weakening, and that allows more of this cosmic energy and this solar energy to impact the Earth. And that's a bad, bad situation. We are nowhere and no way out of the woods. Scientists refer to this era that we are going into as a solar minimum, which lasts for 11 years. And there's a possibility that we have not really even entered into this solar minimum yet, which means the worst is yet to come. So, trying to educate yourself on some of these mechanics, I'll try to help the best I can, but taking into consideration, I've been studying all of this for long periods of time. So, at this point, it kind of comes natural for me. But I want all of you to learn about the dynamics of how these earthquakes occur, these very, very large quakes. So, once again, we can see the energy has burst straight through the Earth, Tennessee, Michigan, and on and on and on. Now, all of these seismograms or these heliplots, they're all going to pretty much look exactly alike. Now, these will update every 30 minutes, and I'm going to be taking a look at them later on after our broadcast. I'm going to see how much more they will change. Now, we're going to go over here to the European seismic department here. And once again, we're taking a look at the Fiji Islands, the epicenter of this earthquake. Now, and this is what I was talking about when I was talking about the lay of the land. What is underneath this part of the ocean and the Coral Sea that you see over here and the Solomon Sea. And you just take a look at this ridge right here. There's always that discussion on how this was formed. If you take a look at the actual ring of fire and you see this lip all the way around, and let me zoom in a little bit more, and you see a continuation of it right here. And you think to yourself, how was that formed? Scientists and geologists, they go back and forth about how this area, how the Pacific Ocean was formed. But folks, whenever we have these earthquakes in this position right here, if you take a very, very close look at these lines. You see these lines and these fractures that go all the way across the Pacific Ocean. They almost look like they were kind of hand-drawn on the floor of the ocean. Was there a massive impact here at one point in time? Or was this just caused by the separation of the land masses? You know, there's always a different scientific opinion on that. But one thing that I do know, just from historical fact, is when these large, deep earthquakes occur in this area, and that magma plume underneath the Pacific Ocean stretches all the way up here and all the way down here. And that energy is very, very deep. And usually it travels this way, straight across the Pacific Ocean. So the chances of a very large earthquake off the shore of Chile or any of the northern South American countries along this border can possibly get hit, and all the way up here into Mexico and possibly even Central America. You know, at this point right now, folks, it's a crapshoot. We're just going to have to wait and see. Now, one thing I want to show you here, and I'm going to go ahead and expand my screen a little bit here, and here's where we're going to get into a little bit of a learning lesson. Now, what I have up on the screen now, let me move these back here real quick. This is our magnetopause. And this small arch in front, this is the Earth right here. You have the white side and the black side, daytime, nighttime. Dotted line going around here is the satellite belt. And this is what protects our Earth from the cosmic radiation from the sun. And you will see this bow shock start to flex. You are also seeing that it is very, very heated by the color code right here on the right-hand side. You can see this flexing because it is being impacted by the heavily charged particles coming from the sun from that massive coronal hole. What is rather mysterious is, as you can see, the illuminated area behind the Earth on the nighttime side, the dark side. Now, over the past couple of weeks, we've been seeing this over and over and over again. Now, sometimes you see a little bit of this influence on the backside, but nothing like what you are seeing right now. So at this time of day here, I'm on the East Coast, and I do believe that they would have been in the nighttime over in the Fiji Islands when this massive earthquake struck. So if you look at the timeline up here for September 6th, this is in UTC time right up here. Look what is occurring on the nighttime side of the planet. Excuse me. So that's what I'm trying to tell you, folks. There's definitely something occurring other than just normal earthquake and seismic activity. What you're seeing right here was definitely the root cause of this earthquake. And this is going to continue. This may just continue for the rest of our lives. This is a very, very, very strange occurrence here, folks. As you can see, this illuminated area, this is not, I repeat, this is not supposed to look like this. No way. And again, if you take a look at the timing, right up here, the date, the time, and you could see the influence right there. Time that with the earthquake, and you'll see the culprit. Now, I'm going to go ahead and get out of the Magnetosphere model, and I'm going to bring up the solar wind model. And this is, the solar wind is actually not a wind like a breeze that you would feel whenever you go outside. When they refer to solar wind, they're referring to these heavily charged particles spewing from these openings in the sun. And this is all coming directly our way. Just to explain this model real quick, again, you have the white and the black side of the Earth, daytime, nighttime. The red arc that you see here, that shows you our bow shock, that imaginary arch where the solar wind is supposed to bounce off of and stream around the Earth. But unfortunately, ladies and gentlemen, that magnetosphere is becoming weaker and weaker and weaker. And that simply means that more and more and more of the sun's deep, hard energy is bursting through. And where does it impact? It impacts our planet. It literally goes right through it, straight down into the core. Now, if you're wondering about the colors, once again, the lower right-hand corner will show you the intensity. The arrows are showing you the way that the solar wind is coming. So naturally, they're pointing to the left. The sun would be all the way out of your picture on the right. The length of these arrows also signify the speed of this solar wind, because this solar wind can be kind of gentle. It could be, 300, 400, 500 kilometers per second. Not per hour, per second. So if you look up here and follow my cursor to the upper right-hand corner, you're going to see the solar wind speed right there. You're also going to take a look here where my cursor is going up and down. You're going to see the intensity as far as the color. You're going to see the pulses coming in. And then you're going to see the blue color is going to be very, very low density, trailing behind the Earth. But at the same time, folks, pay very close attention to this region here. What are you seeing? You're seeing the reversal of these arrows, which means that energy is flowing backwards to the nighttime side of the Earth. Once again, when did the earthquake strike in Japan? 3 a.m. in the morning. Now, I'm not exactly sure of the time in Fiji, but I know they're probably within that Australian time zone and New Zealand time zone, if I'm not mistaken. So they might have been pretty close within that nighttime range. But if you take a look at the direction as this density just pours into the nighttime side of our planet, that to me guarantees that is what triggered that massive 8.1 magnitude earthquake. And folks, I haven't gone back and looked at all of the seismic stations yet, but I can guarantee you that some of those seismic devices probably registered much more and much higher than a magnitude 8.1. The USGS, well, they're just known for downgrading these earthquakes. I mean, they must think that they're really, really fooling people when in fact they're not. But as you can see, this is the situation that is occurring right now. As you're listening to this live stream, we are being pummeled by this solar wind. Massive amounts of it. And just by looking at that Solar Dynamics Observatory model where we see the purple sun, and we see that another large coronal hole is going to be facing us within the next 12 hours. That energy will make its way here very, very soon. So I don't think our planet is out of the woods just yet. We may see this activity from today all the way into the middle of next week. It all depends, folks. There's no real proven science for all of this, but you know, when you watch it, you analyze it for as long as I have, you really start to get a feel for it. Now, this is our magnetosphere. Kind of the same model that we were looking at, but this shows you more of the magnetic field lines of the Earth. I know it looks like a big old jumbled mess of spaghetti lines, but this is dealing more with the magnetism of the Earth, the energy coming from the sun, and usually the black lines, you should see those flowing behind the Earth in a nice, steady stream. Whenever you see them start reaching out, almost like, like the legs of an insect, those lines, the black ones, are reaching for magnetism. These magnetized, heavily charged particles coming from the sun. And then you're seeing very, very large bursts, just a jumbled up mess of the red closed magnetic field lines. You could see the front, which is the bow shock that we were referring to, and you could just see how red, how inflamed is the word that I'll use, the intensity in front of our planet as we speak. The sun is off to the right. So once again, we're not out of the woods. We're actually kind of like somewhere in the middle of, well, let's just say the waiting game. We're kind of right in the middle. We've already had 2 massive earthquakes in less than 24 hours. And we're only about halfway there when dealing with this mess that is coming from the sun. On top of all of this, we have all kinds of weather moving in. I'm going to go ahead and exit out of here real quick. And for all of you just jumping in here, I'll let you take one more quick look at these coronal holes. You're looking at the massive one that is just passing by. And you have this one right here that's going to be approaching within the next 12 hours. Now, there's been a massive coronal hole on the top of the sun now for more than, since 2015. Every now and then it kind of fills in, but the majority of the time, the sun's atmosphere is completely gone. And the outer fringe right here is what we call the corona. Now, this is actually supposed to be the hottest part of the sun. But this is what we're going to be facing with. This angled coronal hole. And as you can see, you'll watch it develop right there in front of your eyes. That will be Earth facing within the next 12 hours. We're going to go ahead and flip over to, I want to just check out some of these. We'll get out of the earthquake information. And I'm just going to check and see if there was any update real quick on this tsunami map. Nope, no update. So you can see right here, no tsunami for your mommy. Okay. We're going to go over here and we're going to take a look at what's actually happening in the Atlantic. I mean, there is, well, here's the remnants of Gordon. That is going to be up in my backyard here in the southwestern Pennsylvania area, around the Pittsburgh area. We are looking at getting approximately, I think it's 5 to 6 inches of rain on Sunday. So you could see the northern tip of Louisiana here. I know that probably doesn't look too good for some of you. I'm going to go ahead and flip over here. Here is Invest 92E. This is another tropical storm that is actually forming. Invest 92L. And here's Florence. You know, folks, we have some systems out there in the Atlantic that are forming. And one of these is they're mapping. The models are showing that this is mapping straight for the East Coast of the United States. And I'm hoping and praying that it doesn't, because the way that the models are looking, let me go ahead and jump over to some of these forecast models. I'll show you real quick here. I'm going to go ahead and set this into motion, but I want you to pay very close attention down here. Okay, you're going to see, well, that's what's coming up over me now. Here it comes right there where the red L is. Boom! That impacts, skirts along the coast of New Jersey, slams right into Long Island and Manhattan. And we're going to go ahead and let that play over again. But this huge swath of weather is coming up right into my neck of the woods. It will be here. Well, it's actually raining right now, but it has not too much to do with what just came up from the Gulf of Mexico. But you can see that low pressure, that is not looking too good for the folks on the East Coast. Specifically, anybody in Jersey, Philadelphia, Long Island, Manhattan, New York City, the whole entire state of Massachusetts. As you can see, it rolls right up through there. And we're looking right up here, folks, right up here. And this is all going to be next week. So I'm going to go ahead and just pan down, and you could follow the date up here. I do believe that that arrival, let me just open this up a little bit. I do believe that arrival is on the 13th going into the 14th. So that would be next Thursday, Friday, and Saturday as that system rolls in. And there's another one right behind it. And that one kind of looks like it's going to skirt further south on the east coast of the United States. But here it comes. You can see it. I mean, that's pretty much the worst side of the storm. So I could definitely see, a lot of storm surge moving into Delaware, Rhode Island, South Jersey, North Jersey, a lot of beach erosion, possible flooding. It all depends. But folks, the lower the pressure in these storms or hurricane, the more power and the more energy that they have. Now, this is an extended model, okay? Anything could change in a heartbeat. And the reason why I'm saying that is because if you watched my live stream from last night, I showed you guys how erratic the jet stream is. It is an absolute mess. I don't even know how professional meteorologists are able to correctly forecast the weather. At least, at extended periods. Because this jet stream is just constantly changing and constantly so erratic. And a lot of that has to do with, what's kind of lurking out there in space, what's happening with our sun, the massive ice melt in the North Pole. And we might as well throw in some geoengineering and some climate control by the governments. So there are so many factors that we are facing right now. And I'm pretty sure that the flooding through the central Ohio Valley there is going to be pretty extensive. I was looking at some photographs and wrote an article about what just happened in Kansas. Absolutely devastating. Just massive amounts of water. And you can see there is a pretty heavy storm system that's moving right over top of me. I'm down in the southwestern corner of Pennsylvania here in the city of Pittsburgh. If you just follow my cursor, I'm right down here. So it's not looking too good. I am not in a low-lying area. However, we have a lot of hills and valleys around here, a lot of rivers, and I can see it already. 5 to 6 inches of rain over a period of just a few hours is going to be devastating. We may just have our own natural disaster here going into Monday morning. I'm going to go ahead and jump out of this model. And we're going to go ahead and pull up some windy.com. And we're just going to check out some of this weather. And we're going to go ahead and let this run out. And right now we're just looking at, what do I have this set on? We're going to go and set it for the wind. And these are, let's get up here to the millibars for hurricanes. So I'm going to go ahead and zoom in here, and this is going to go ahead and you see the little time stamp down here. So we're going to watch this roll out to Saturday the 15th. And this is the GFS model. And let's see how it brings it. And this is the storm that I was watching and I was just showing you guys that may possibly roll in and slam the upper East Coast. You can see this model already right here bringing that massive swath of moisture and storms my way. And that's going into Sunday. So it's not looking too good for people in my area Sunday and Monday. This is actually going a little slow because it's extended all the way to Saturday, September 15th. But this is the area that we're watching right here. This will let me convert this over to knots, from knots to miles per hour. So it's not that bad right now. But if you get closer to the center of that storm, you could already see 97 miles an hour. Let's see, we get a little closer to the eye of the storm. It's very, very calm. So we'll just kind of move out here a little bit. So it's kind of close to 100 miles an hour. But let's just see how the GFS model brings it into the east coast of the United States. So right now we're on next Tuesday, the 11th, at about 4 and 5 p.m. My worst fears is, when these storms hit at nighttime or high tide. That also makes matters worse. Now, this model right here is bringing it directly into the Fayette, North Carolina area and the Outer Banks. But then you see it's going to travel straight up through Delaware, Rhode Island, Maryland, Washington, D.C., and then a pretty hard impact skirting right along the coastline. Now, I'm going to zoom in here. For all of you people that live on the East Coast, folks, you at least have some time to prepare for this. The strongest areas of these storms and these hurricanes is this upper quadrant as the air rolls over. As you can see here, in case some of you guys don't have your glasses on, I know we have a lot of people with MFA that live in this area. I have friends and people that I know very, very well all live in this area. What you're seeing here is just the coastline of Long Island and New Jersey just getting battered. If this storm gets hung up and it starts to sit there and it's slow moving, it's not going to be a nice day on the Jersey Shore. That much is for sure. So folks, for any of you that live in this area, now is the time to just make some preparations. You have an entire week before this storm gets here, unless something changes in that jet stream and it starts moving faster. Let's just hope that it does not pick up with intensity, because it will destroy all of the beaches. Once again, in Jersey will be an absolute mess. So I'm going to go ahead and pan out. You can see the size of that storm. Not only do we have this one to contend with, those folks out in the islands over here, they better watch that storm also. But right down here, getting very, very close to the southern Caribbean, another storm. Oops, I zoomed in a little too much. So by looking at the weather patterns, or excuse me, the air patterns, that just might scoot right in here to the lower Bahamian Islands. That might move right up into South Florida. And they were just battered with a lot of rain from the last storm that rolled in a couple of days ago. I'm going to go ahead and let this continue to the end of the 15th. And it looks like this model is actually pulling it away from the coast, but not before all of the damage is done. Now it looks like this system here is actually getting sucked up with this old system out here. So, I mean, the model ends right there, but I will already be soaked here in my neck of the woods. So will everybody in the Ohio Valley, everybody along the Appalachian Mountain Range through here. You're looking at a very, very good soaking. Possible flood damage through Tennessee, Kentucky, West Virginia, Ohio, southwestern Pennsylvania, and so on and so forth. So, folks, let's just say, let's split the United States right in half. Everything east of the Mississippi River, just get yourself prepared. For you folks on the east coast of the United States, next weekend, be prepared. You know, guys, get yourself a flashlight. Get yourself one of them LED flashlights, because they actually use less energy than the old-fashioned flashlights. And I'm going to go ahead and flip over here to this other model. We were actually using another model there, but now I'm going to back this up here because I want to see once again, we're going to use the GFS model. I was actually on another model. I apologize. But it's all going to be pretty much the same. But getting back to your preparation, soon enough, whenever the website is going to be completely finished for the MFA Media Group, we're going to have a survival link on there, and we're going to have survival gear, we're going to have survival products and things of that nature. We're going to have a lot of information on there that's going to teach all of you some of the things that you really want to learn. Now, I'm not some big-time survivalist, but I feel at home in the woods. I feel that I could survive. I've been doing this long enough. But preparation, the basics, if you're stuck without power, you want to have something, batteries, a flashlight. You want to have that emergency first aid kit. Taking into consideration, maybe you slip, fall, cut yourself. Listen, you want to be able to take care of that instantaneously. You don't want any of this yucky water getting in open cuts, because Lord only knows what type of bacteria can enter into your body through an open wound. You want to have food, and naturally, if you don't have power, the food in your refrigerator is going to go bad. But that's why you need canned goods. So, head out to the grocery store, pick up some canned goods, and a lot of the canned goods nowadays, they have the pull top tabs on them where you don't need a can opener. And hey, maybe you have to eat a can of cold Chef Boyardee raviolis for a day or two until you get some power. Or whatever it may be, a can of baked beans, or a can of Dinty Moore stew. But at least it's food in your belly, and you're keeping yourself nourished. Make sure that you guys have plenty of bottled water, filtered water, because usually when you get this type of flooding, some of the reservoirs, they tend to get flooded, and the water is not good to drink. So again, just some of these minor preparations. And folks, get a weather app of some kind on your cell phone. We are actually working right now on an MFA Media Group app that will be $1.99 a month. Now, some people may hem and haw about, oh my God, I got to spend $1.99. But folks, these technical things are not cheap. They are not free to run either. I have several weather apps on my cell phone that I pay $5.99 a month for, and I don't complain about it. Why? Because it's useful. It helps me. And $1.99, oh hell, if you look under the seat of your car once a month, you probably have $1.99 worth of change laying underneath there or in your cup holder. So we're going to be rolling out that new MFA Media app, and we're going to have all kinds of bells and whistles on there to keep you guys in tune with what's going on. Our website's going to be done, probably in 2 to 3 weeks. We're going to roll that out and fine tune it. So what I am going to ask each and every one of you is that you really, really start to talk to other people about this organization. Bring them to our Facebook page. When our website is finished, bring them to our Facebook page, our website. Let them know what is happening. Folks, I can see now that more and more people are truly waking up, because they're wondering why are all of these things happening? If you listen to mainstream media, they don't tell you anything. All they talk about is Donald Trump. That's it. Instead of letting the man run this country and do what he needs to do, they sit there and they conspire, but it's all just a game, folks. A lot of people ask me why I don't talk that much about politics. And that is why. Because it's all deception, ladies and gentlemen. Just take a look at it. Just watch the news, mainstream media. Just watch it for 1 hour if you can stomach it. I actually sit back and have a few laughs while I'm doing my research and my work and writing some articles. But that's where we're at today, folks. Another blasting earthquake in the South Pacific. Yesterday, another blasting earthquake in the North Pacific in Japan. I feel so bad for those people because I know that there are more people that have passed away in that earthquake. Those landslides were just absolutely devastating. I'm going to see later on this evening if I can get an update on what is actually occurring over there in Japan. I have a couple of feeds directly from Japanese news stations. And that's one thing that I love about that country, is they don't lie to their people. They put it on the news. They tell you straight up, share the information, man. Share it. People's lives depend on it. But here in the United States, we deal with censorship from social media. And if you guys from social media, like you CEO guys and gals are listening to me now, you should be ashamed of yourself. You should really, really be ashamed of yourself. Not allowing the proper information to flow, to save lives. And one day, maybe that information that should have been flowing, maybe that takes somebody away from you that you loved and you cherished. Think about that. That's hardcore. That is the truth. That is what MFA Media Group is going to bring. Stone cold, hardcore truth and accurate reporting with a ton of knowledge. Remember what I always say, folks. Knowledge is power. When you have that power, you have that knowledge. Everybody, please watch out for the weather, no matter where you're at in the United States. It's going to be brutal here and there, so keep your eyes and your ears open. I will probably have an update later on this evening for all of you. I'm sure that something else will occur. It's just the way things are in our world today. This is Scott for MFA Media Group. Have a good afternoon, folks. Stay safe and stay safe and take care. I'm sorry about that. I got a little tongue-tied. Take care, folks.